Alright. You guys have some traction tiles. And we also have circle pieces if you want to use those. And I want you guys to see if you can come up with ways to identify how much was removed and how much is remaining.
So I guess we had.
Now, can somebody tell me what that odd symbol?
You want to work with the circles, Julie? We can circle it together.
Perfect. I don't really know where I was going with this.
I don't either. No clue.
Well, it was like
Mine are like glass. So he did 2/3.
that's what it looked like to me. I don't know.
So here's our hole.
Oh, cool.
I know, but these are look at they're like plastic and see-through.
I like these.
So that would be 2/3, right?
Yeah.
Where's the other third? Where's the other third?
So it's about how much she drank to me.
Maybe like a cup and a half or 2.
And are we guessing cuppage wise, or are we guessing
Yeah.
cuppage? So how much do we think he had at the beginning?
Do it.
Are we,
It's hard to see because you don't know how wide the cup is.
Yeah.
is that the same as his cup?
It's similar. I have it. So I'm going to dump out how much they dumped out. And you guys can kind of visually look at it. Try not to look at the numbers though.
Okay.
You are going to this open line here. And how would you show me, if I were a kindergartner, the difference in temperature?
You know what you're having yet?
Oklahoma
Oh, that's cute.
And it was filled up to here.
It was filled up to there?
I think my original guess might be off.
It almost looks like 3/4, which would be the same as 2/3. Equivalency wise.
My measuring cup's a little funny shaped. So that plays a little bit into it.
And if we 3/4,
Yeah, maybe it's like
do you think it's, how many cups do you think we started with though? She said not to look at the numbers, so don't cheat.
my eyes look irritated.
So we also think he made 3/4, right? 3/4 would be the same.
Kind of eyeballing it.
Yeah, but I think
These are 4s,
4 would be too small because like I can't imagine 3/4 on top of
I
that.
think. Yeah.
Yeah.
No. Yeah. Okay. Okay.
Massive
Okay.
numbers.
So
Definitely more than a cup. But I feel like it wasn't 2 cups.
I feel like so if we think he drank 3/4 and let's say that the 4th is a denominator and that's how much we started with, that means we think he drank 3 cups.
Oh.
Did he drink it or did he just dump it out?
It's a similar, like, amount was removed, not necessarily cup wise.
Alright, so you're gonna
So it's
try,
ratios.
you're gonna
So
try
Favorite word today.
you really do like it.
My lesson's about it, so it's just all coming back to me.
so that you're gonna have to
Eyeballing. I'm gonna
So you
say.
guys think, what are you guys thinking?
We thought a third.
you're gonna have to discuss.
So we think he dumped out 3/4 of it,
Okay, so
or 2/3.
what is your tiles representing?
So these are 4s, and there's 3 of them.
Okay.
The ones underneath. Oops, I removed too much.
If you want, that's fine.
No, I did not. And that's 2/3, which could also represent it.
What are other ways you could show 1/3?
1/3,
Like, or 2/3?
or
Using different pieces. How many different ways? Can
well,
you
we already
do
did
that?
those.
Oh.
Those are
And what are
4s.
your ways? Let me know what your ways are and we'll write them
You
down.
said 2/3, like be the orange and the 2 yellow.
So we're trying to equal 2/3.
4/6.
4/6. Show me with your tiles too.
Do we have that many tiles? I'm trying to stack it.
I'm sorry, did you say something? No? Okay. 8/12. How do you know that?
Because I'm about to show you with
All right.
The sass.
Do what?
Oh, I'm stacking these.
Okay.
So you can just grab from the pieces.
Yeah, just take that from all. Some ones. And then there's ours. And here's ours.
The puppy one.
We're just gonna, now we're gonna move on and then try and find and see how.
I don't think fits can go into this.
I like these better than the fraction tiles.
They really helped me out immensely.
Where did you get them?
They were in my bag from the blue bag.
I don't have these.
Maybe I bought them. I could have bought them.
I was like, I don't have those either.
But I really enjoyed those.
I had to create my own of those.
I'm trying to follow you with my camera as much as I can.
Oh, okay. Thank you.
You're welcome. That way, when you watch yourself, it's really cringy. So we're making 2/3, 8/12. Is there any more that we can make?
That's a good question. Is there?
I'm thinking, do we have that many pieces to make more than 12?
What's another way you could do it if you're unsure if they equal?
Well, you could start mixing friendlier numbers, I guess.
Like, how would you mix friendlier numbers?
Like you could do thirds and sixths together.
So what would equal 2/3?
3 orange pieces.
That
Or
would be a whole-
2 orange pieces. Sorry.
What do the orange pieces represent?
A third.
They represent 1/3. So you could have, that would be the same as 2/3 or 2, and then we'll do 1/3.
10/15. So that right there. Wait.
Well, it's going to be a multiple of 2. So that's how we're increasing it. So that would be 16 over 24.
What you got going there?
5/10 and a 6.
5/10 and a 6.
Oh, see, now I'm jealous because she's got tiles and we're over here just
Yours are labeled.
we're just over here piecing pizzas together.
Well, this could also be like a gifted for gifted students to figure out. The unlabeled ones, while the labeled ones help.
So if we know these are thirds, these are fourths, these are probably what, fifths? These are sixths, these are sevenths, these are eighths, so these are ninths probably, right?
Yeah, we're not gonna be able to.
So ours doesn't go up to 12s.
Yeah.
Ours goes up to 9s.
I have another set here too. If you guys need another set.
3 tenths. And
So I like what you got going. What is
3
that?
eighths. 3 eighths and 3 tenths? Well, I guess a fifth and eighth, a fourth and a tenth.
Fifth and eighth.
So here is, that's here is 2/3. So now we can start stacking them to see what we can make. We know these are thirds, these are fifths, these are sixths.
Oh, it's a big long one.
It works, right? I'm not crazy? No, I'm not.
You could. What other ways could you test to see if it works?
What are these?
Very pretty.
I can't tell. No, they're the same. They're the same. They work. It works.
We are looking for what?
These are sixths and these are what?
2/3. So you could take
Sevenths? They can't be sevenths. Those are fifths.
I was looking for
Those are sixths. I need to know what these are. Maybe eighths?
3, 4, 5, 6, 7. Yeah, that's 8.
You think? Okay, so we have 2 sixths and 3 eighths make it. Listen to me.
Huh? Nice.
We have 2 sixths and 3 eighths make up 2/3.
How would you apply your strategy?
What do you have?
2 sixths and 3 eighths make a
2
third,
sixths and
or
3
2/3. Yes.
All right. Do you guys want to trade and see what the other pieces look like?
But then I have to put all these back.
You can make.
Stack them.
Yeah, my friends over in the house.
Throw them in
I
there.
feel like I'm gonna do this.
Don't throw them.
There you go.
Yeah. And we grab us some tiles.
Yeah, virus.
Oops. Let me scoop my mess over for you. So that's a whole. Then we need 2/3, which is the orange pieces.
Where is our 2/3?
And we know 6 fits into them.
What does your whole represent?
3/3.
Huh?
3/3
Yes.
water.
3/3 of water. 2/3 of water. Or 2/3.
But the whole is 3/3 of water.
Yes. So you would write that 3/3?
Uh-huh.
Do 2/3 because these only go into fourths. 2 pieces would be a quarter. So we have to use.
Oh, I like it. I like that you pulled the 1/8 that we did. Does it fit? It does not fit. So those were not 8s we were doing. Those were not
Rewind.
8s. That does not work.
So you're saying that one does not work?
Nope.
All right.
You think 10's work?
I don't think so.
Oh, just shy.
So it has to be 12s. There's no way that was a 12. There's no way
Try
that's a 12.
8s?
There's no way that that's a 12.
Would 8s?
What's a way you can figure it out?
We already tried 8s. It's
Oh,
too
you did?
big. Yeah.
Oh, another one? Oh.
1 6, 2 1/6, and 4 1/12.
So 1/6 plus 1/6 plus
4,
4 1/12.
1/12 plus 1/12.
essentially 4 12s.
And we found the degree difference was.
Maybe it's 40.
Well, you could do like we did with
It
the
might
block.
work. That might work.
It
It works.
Oh, I like that.
Puzzle pieces together.
So that is
3 1/8 and 3 1/10.
I'm getting.
I think another 5th will fit. I think it will.
These are the 6.
No, I think another 4th would fit.
1 5th. 2
1/5
1/4
and-
and 1/5.
Yeah.
No, too big.
So little.
Maybe a 6th? Yes.
all right.
2 1/4 and a 6th.
So Erica enters what they did was, it's telling me they each find a number.
It's wonderful.
1/6, I think.
What do you see there?
Ooh.
Can you make any connections?
Yeah, I know that 2 1/4 equals a half, so that makes sense that a half would fit that part of it.
I like the color of pink. It's nice.
So 1/2 plus 1/6.
Yeah.
Yes.
So there's 10 here, 10 here,
Oh yeah, that's only just
10 here.
right.
Okay, so then
I might have been listening.
All right. So let's change the situation. I want you guys to still use your titles if you need them. But let's say this was 4 cups full, and now we're down to 1 cup. But it's 1,000 liters. How many liters are remaining? Yes. With 4 cups, it equals 1,000 liters. There's only 1 cup remaining. How many liters is it?
We have 1.
So 1,000 divided by 4.
4 cups.
So it would be
2.
And we want to know how much 1 cup is.
250.
So there's 250.
250.
250.
Oh, God.
How do you know?
Because we know that if we divide the 1,000 up by 4s, then that's how many goes into each cup.
And I know
What would 1
that
cup represent? It would represent
250.
250 milliliters.
okay, and a quarter. So 1 cup would represent a fourth,
I,
and that would be 250.
I know that 250 plus 250 equals 500, which is half of 1,000.
So 2 cups would equal
500.
500, and 3 cups.
2/4 equals 500. There.
And what is our 3 cups?
750.
3/4.
All right. What if we changed it? And we said we had 900. 4 cups equal 900.
Oh.
You would divide the 4 into the 9.
And say 300. No, less than 300. I know, because that would be thirds.
It would be a decimal. It would end up being a decimal.
24 check marks away from 0.
What about
Can you guys
275?
guesstimate it?
275.
275?
Check marks here? Yes.
Because I know 250 is too low. So
250 is too low.
yeah.
Because right here, for 1,000, 250 equals
Is
1
it?
cup.
Mm-hmm.
Right.
And then you just count all the check
Where
marks.
is it? Do you guys know what this top number is called?
Numerator.
Numerator? What does it represent?
The
How many
parts.
holes, or how many whole parts of the whole?
How many whole parts of the whole?
Yes.
Okay.
Sorry.
So it represents how many parts are in the whole, right? That we currently have.
That we, yes.
And what does the bottom number represent?
The number of holes.
Equal
Do
parts.
you guys know what that bottom number is called?
Denominator.
The denominator. All right, today you guys were able to decompose numbers. And so when you decompose fractions, you're actually saying this, you're chunking it. 1/6 plus 1/6 plus 1/12 plus 1/12 plus 1/12 plus 1/12, which is a lot, equals 2/3.
Is there an easier way to say that?
There is. How could we say it easier?
2 sixths plus 4 twelfths.
Okay, so we have our
Making
2/6.
friendly numbers.
We have our 2/6 here. And that's the same thing we said when we said 1/6 plus 1/6 equals, yeah, it equals 2/6. And then when we said how much here?
4 twelfths.
412.
4/12. Can we do that for this one too?
Uh-huh.
Yes.
What would it be?
3/8.
3/8? Because we have 3 of them.
Mm-hmm. Plus 3/10, because we have 3 1/10.
Right.
But I thought you had to have the same denominator to add stuff.
You actually don't. So if you take your tiles and you lay them out, and let's say we use thirds and sixths, can you show me how many thirds fit into 1/6? Or
Yeah.
I'm sorry, how many sixths fit into 1/3?
1, 2, 1, 6 each fit into 1/3.
So is it the same when we say 2 6 equal 1/3?
Yes.
What do you notice about the top number and the bottom number?
They multiply by 2.
They're even.
They both are even. So could we divide this by something? And we're going to do the same thing to the bottom as we do the top. So how many times, or what number do we want to choose?
2.
2, because we know it goes into both of them.
Uh-huh.
How many times will it go into the bottom number?
3.
How many times will it go into the top number?
1. Ah.
So it's just showing that the representation of 1/3 is the same as 2 6. We just have more pieces of a pie. The pie is the same size. We just cut it into more pieces to feed everybody.
Now I want pizza.
I know. Me too. All right. What patterns did you guys see whenever we were changing our fractions? Like we talked about this one. What other patterns can we see? Let's say 1/8 and 1/4.
They were all multiples of each other. Like 4 can be multiplied by 2 to get an 8.
So if we were to take this and do the opposite, what would we have? If we try to make this one an 8,
Multiply.
how many 8s would we need to make 1/4?
How many 8s would we need to make 1/4, or how many 4ths would we need to make an 8?
How many 8s would we need to make 1/4?
Half of one.
Half of a fourth?
Half of an 8th to make a 4th.
No, she's saying how many eighths will go into 1/4.
Yes.
Oh, okay. So yeah, 2.
2. And again, like what we did earlier, we're seeing that 2 will go into both of these, and that's how we get back to this one. So they're equal to each other, right?
And so then the bottom equation is 3/8 plus.
With this one right here?
Yes.
Okay, so let's see. You want to combine these to make it 3/8, and then you're going to combine these two
To make 3/10.
to make 3/10.
Because that's a 5th.
It equals 2/10.
Oh, okay. Okay. Okay.
All right.
Okay, then.